Welcome to the deep dive.
Great to be diving in.
So today we're trying to connect the dots, maybe, between two incredible ancient sites using the sky.
Yeah, we're looking at the Great Sphinx in Egypt and then Göbekli Tepe over in Turkey, which is much, much older.
Right. And the idea is to see if these ancient people oriented these places based on what they saw up there,
Exactly. We're focusing particularly on the sun, naturally, but also the bright star Regulus.
and how they appeared during things like equinoxes and solstices across huge timescales.
And we've actually got some pretty detailed astronomical calculations to work with, so let's see what they tell us.
Okay, let's dig in. Where do we start? Göbekli Tepe.
Makes sense. It's the older one by far. We're talking around 9,000 BC.
Wow. Okay, 9,000 BC. That's hard to even wrap your head around.
It really is. It predates the Sphinx and the Giza pyramids by millennia. The Sphinx is what, maybe 2,600 to 2,400 BCE? Much later.
So, yeah, vastly different times. Let's look at Göbekli Tepe first then, back in 9,000 BC. What did the sky look like?
Okay, so we have data for the key moments, spring and autumn equinox, summer and winter solstice.
Altitude and azimuth, right. How high in the sky and which compass direction?
Precisely, for the sun and for Regulus. And we have it for 9,000 BC, 8999, 89998. So you can see the small year-to-year shifts.
Okay, give me an example. What about the spring equinox, 9,000 DC, say midnight?
Right. At midnight, spring equinox, 9,000 BC at Göbekli Tepe, the sun's way down. Altitude minus 56 degrees, azimuth about 74 degrees, so below the horizon over towards the east-northeast.
Okay, sun's down. What about Regulus?
Regulus is the interesting one there. Altitude almost 65 degrees, azimuth just about 6 degrees.
Whoa, so nearly straight up, just lightly north of east.
Basically, yeah. Very high in the sky. Prominent.
That feels significant, especially in the spring equinox.
Well, you have to think, for a culture building something this monumental so early, a bright star nearly overhead at a key seasonal moment, it's certainly suggestive.
It makes you wonder, yeah, that connection to the cycles, the sky.
It must have been profound.
Okay, so that's Göbekli Tepe, 9,000 BC. Now let's jump way forward. Well, sort of. We have the same data for Giza, same time, 9,000 BC.
We do, yes. It helps establish a baseline, even though the Sphinx wasn't there yet. It shows how location changes the view.
Right, so same moment, spring equinox, midnight, 9,000 BC, but now at Giza.
Okay, at Giza, sun's even lower. Altitude minus 64 degrees, azimuth 79 degrees. Still generally east, but further down.
And Regulus, still high.
Still high, yes. Even a bit higher, almost 70 degrees altitude. But the azimuth is different, about 31 degrees, so more towards the northeast.
Interesting. So same star, same time, but looks different depending on where you are. Makes sense.
But here's the crucial thing we need to remember, especially when we talk about the Sphinx itself.
Which wasn't built for another, 6,000 years or more?
Exactly. And over that time, the sky changes. It's called the precession of the equinoxes.
Right. The Earth's wobble, like a spinning top slowing down.
Precisely. It's a very slow wobble, takes about 26,000 years for one cycle, but over millennia, it shifts where the stars appear relative to the seasons.
So the Regulus they saw in 9,000 BC is not where Regulus would be when the Sphinx builders were around.
Not exactly, no. Its relationship to the sunrise on the equinox, for example, would change.
Okay, so that 9,000 BC data is context.
Yeah.
Do we have data closer to the Sphinx's time, maybe around that 2,600, 2,400 BCE period?
We do have some relevant data focusing on the autumn equinox at Giza a bit earlier and around that time, looking at roughly 3,000 BC down to about 2,400 BC.
Okay, autumn equinox. What are we seeing then? Still looking at Regulus.
Yes, Regulus and also another star in Leo Algebra. Let's focus on Regulus for a sec.
Right.
So autumn equinox, 3,000 BC, let's say around 5 a.m. Regulus is up, altitude about 23.5 degrees, and its azimuth, 90.55 degrees.
90 degrees, that's due east, right?
Pretty much exactly due east. Now, fast forward about 500 years, say 2473 BC. Autumn equinox again, maybe 6 a.m. this time.
Okay, what's Regulus doing now?
Now it's much higher, altitude over 41 degrees. But the azimuth, still right around 90 degrees, 90.99 degrees.
Wow. So consistently rising almost exactly due east around the autumn equinox during that whole period leading up to and including the likely time the Sphinx was built.
That's what the data suggests. And remember, the Sphinx faces due east.
Right. It gazes towards the sunrise on the spring equinox.
Correct. But here we have Regulus, a major star, also rising due east. But around the autumn equinox, during the centuries, the Sphinx was likely carved.
Okay, that is interesting. a potential link.
It's a correlation, certainly. You have the monument facing east and a prominent star rising east at the other equinox during its construction period.
So stepping back, Göbekli Tepe, 9000 BC, Regulus is super high around the spring equinox. Thousands of years later, Giza, Regulus is rising due east around the autumn equinox near the time the Sphinx is built.
That's the picture, yeah.
Could there be some continuity, like a persistent focus on this one star across cultures and millennia?
It's definitely a possibility worth considering. Regulus is bright, it's noticeable, part of Leo, the lion constellation, which obviously resonates with the Sphinx.
True, and the precession, that slow shift. Maybe they tracked it. Maybe its changing position gave it different meanings over time.
Perhaps. Maybe its significance shifted from the spring equinox marker in deep prehistory to an autumn equinox marker later on. We can't know for sure.
And that's the key point, isn't it? We see the alignment in the data.
Yes, the numbers show what happened in the sky.
But the why? Why they might have cared, what it meant to them. That's still interpretation.
Absolutely. We have to be cautious. These were complex societies, separated by vast time. Attributing intent is tricky.
But it's hard to ignore. The consistent visibility of Regulus, its connection to these key solar moments, east-facing alignments, it feels like more than coincidence.
It does suggest the sky was deeply woven into their worldview, maybe even into the very blueprints of these incredible structures.
So when you think about it, looking up at the stars tonight, you're seeing patterns that people were potentially aligning monuments to thousands and thousands of years ago.
It connects us, in a way, that shared view of the cosmos. It raises the question of just how central that celestial observation was to their lives, their beliefs, their engineering.
Yeah, these alignments, they're like echoes of that ancient focus.
It's quite profound when you consider it.
Okay, so here's something to chew on. We see these intriguing patterns with Regulus, at Göbekli Tepe and later at Giza, spanning huge stretches of time. Could this point to some really ancient, shared cosmological idea, maybe a tradition about this star that lasted and changed, but kept influencing how they built things?
A kind of celestial lineage, perhaps?
Maybe. And it makes you wonder, what other stars were they watching just as closely? What other alignments are waiting to be understood, telling different stories about how they saw the universe?
That's the big question, isn't it? What else is written in the stones and the stars?
Definitely some astronomical food for thought. Join us next time for another deep dive.